A mysterious visitor is on its way to Earth, moving closer, 137,000 miles per hour. Is it an alien ship, a comet? Scientists and researchers are...
A strange visitor is making its way to Earth. Approaching at a breathtaking 137,000 miles per hour, it slashes across the celestial emptiness with an aura that cannot be denied. Is it an extraterrestrial spacecraft? A comet? A shard of some lost star system? Scientists are left bewildered, torn between exhilaration and trepidation. Out there, in the big empty spaces between stars, something is moving, and moving very quickly. This is not something from around here. It's older than Earth itself, and it's arrived oozing secrets through space. For the third time in human history, a piece of another solar system has come into our own. The first was the mysterious, cigar-shaped Oumuamua, which came in 2017. The second was 2I/Borisov in 2019, a more conventional-looking comet. And now, this third interstellar traveler comes, and NASA officially names it 3I/Atlas. But what the James Webb Space Telescope has recently observed left scientists across the globe amazed. This object is not merely a rock floating in space. It's emitting huge quantities of carbon dioxide with hardly any measurable water, shattering all comet chemistry rules ever observed. It doesn't behave like any comet previously known to man. It doesn't belong here. And the Webb's new high-resolution photos and spectral readings tell us something stranger still. Only the third time in all history, telescopes all over the globe have seen something from outside our solar system. The possibilities are mind-bending. Could it be a time capsule from a long-lost region of the galaxy? A message from the cosmos scrawled in molecules? Or, more sinisterly, a warning? Whatever it is, NASA is gravely concerned, and humanity might soon have to deal with questions it isn't prepared to answer. The name is official, 3I/Atlas. To the astronomers monitoring it, however, this isn't a mere object. This is an anomaly. Far out in the desolate bone-dry Chilean Atacama Desert, where air is so thin and dry that it is like inhaling dust, the Atlas telescope initially observed something impossible. It was July 1, 2025, 4:30 a.m. local time, when the faint smudge of light first materialized. At magnitude 18, it was just visible against the twinkling background of stars. But within a few hours, astronomers knew they were gazing at something phenomenal. The smudge was too fast-moving, following a path that told an older story than our planet itself. This was not an inhabitant of our solar system. It had come further than anything human beings had ever seen up close. But why precisely is this discovery so disturbing? To see, we must look back. Oumuamua had been quiet and tumbling, a dark, cigar-like body that stubbornly refused to share its secrets. 2I/Borisov was like a classic comet, acting according to established models. But 3I/Atlas was different altogether. Rather than spewing water ice like all other comets, it was bleeding carbon dioxide in unprecedented amounts, with hardly any water vapor at all. That alone rewritten the textbooks. Every comet we've studied in our solar system follows a basic recipe: water ice dominates, mixed with traces of other frozen gases. This is the chemistry that reflects how our solar system formed 4.6 billion years ago. But this visitor? It was alien to that chemistry. 3I/Atlas has an unbound hyperbolic orbit beyond the Sun, possessing an excess speed of almost 130,000 miles per hour compared to the Sun. Such velocity speaks to an ancient history, one of unimaginable time and distance. To have gained such speed, 3I/Atlas would have had to plummet through stars and planets' gravitational wells throughout the galaxy for billions of years, picking up speed along the way. And here's where the eeriness deepens. It entered our solar system quietly, approaching from the direction of the constellation Lynx. No fanfare. No advanced warning. Just a cosmic interloper carrying with it the chemistry of a place we've never sampled. Trajectory analysis uncovered something that ought to make anyone take a step back. This comet appears to have formed in the Milky Way's thick disk, which would have made it at least 7 billion years old. That would mean 3I/Atlas was already old when Earth was still a molten ball of rock. It was wafting through space when the first signs of life emerged in our oceans. This is not a rock. It's an ancient relic of the galaxy's childhood. And when the James Webb Space Telescope fixed its golden mirrors on it, things only became more bizarre. By mid-2024, NASA had assigned Webb a single goal, 3I/Atlas. The telescope, almost a million miles from home at the L2 Lagrange point, pointed its enormous 21-foot-wide golden mirror toward the guest. Webb was built to explore the most ancient galaxies, exoplanets, and distant light from the universe's dawn. But it was about to redefine comet science instead. Expectations were modest. Astronomers believed Webb would validate 3I/Atlas as a pretty run-of-the-mill interstellar comet, loaded with water and known ices. They were mistaken. Webb's near-infrared spectrograph detected one of the highest ratios of carbon dioxide to water in a comet ever recorded. Not only unusual, historic. The spectral lines were unequivocal, carbon dioxide emissions burning bright at 4.3 micrometers, while anticipated water signals at 2.7 micrometers were weak to non-existent. It wasn't simply a case of weird chemistry. This was impossible chemistry. Rather than water ice making up most of its nucleus, 3I/Atlas appeared to be releasing almost 8 times as much carbon dioxide as water. To put it into perspective, in our solar system, comets nearly always develop outside the snow line, where water ice is the predominant substance. CO2 takes on a supporting role. But 3I/Atlas had turned that ratio entirely on its head. NASA researchers continued to monitor their equipment, certain there had to be some mistake. They recalibrated. They reworked the data. But the measurements remained constant. This comet developed in conditions that don't exist in our solar system. The proportions spoke a forbidden tale. The ratio of CO2 to water was 8:1, a record for any comet. The conclusion was astounding. Such chemistry suggested a place of origin far out of any possible habitable zone, maybe in the ancient depths of the galaxy's dense disk. This translated to 3I/Atlas potentially revealing a snapshot of what was present billions of years prior to our Sun's formation. And then another telescope verified the impossible. In August 2025, NASA's SPHEREX mission, intended to map the entire sky in infrared, turned its gears toward 3I/Atlas. SPHEREX wasn't constructed for comets per se, its noble purpose was to examine cosmic inflation and the early universe. But when mission controllers repurposed it, the findings were breathtaking. Between August 8 and August 12, SPHEREX verified all Webb had observed, and more. The CO2 signature was blazing bright at 4.3 micrometers. Water was again nearly non-existent. But SPHEREX uncovered something new, asymmetries in the coma. The outgassing wasn't even. Sections of the comet vented CO2 in organized patterns, as if it were a comet with areas of activity rather than a mere melting ice ball. This wasn't haphazard. It appeared complex. Almost intentional. Dr. Jamie Bach, principal investigator of SPHEREX, said. "We've observed thousands of comets and icy bodies. There's nothing like this. The chemistry is extreme, so extreme that it makes us rethink how planetary systems are formed throughout the galaxy." For the first time ever, 2 standalone space observatories had confirmed the unthinkable. 3I/Atlas wasn't only unusual. It was alien to all we knew about the formation of comets. In the background at NASA's Goddard Space Flight Center, coffee went cold as researchers huddled around monitors, gazing at the data. Emergency video conferences were convened across time zones. The James Webb and SPHEREX had made a 1-2 punch, and now the astronomical community was reeling from shock. Dr. Michael Kelly, a University of Maryland comet expert, explained it thus. "This is not just a strange comet. This is proof of planetary formation mechanisms we don't observe in our solar system. It's chemistry from somewhere else altogether." The controversy raged. Some called for restraint, reminding peers that extraordinary claims need extraordinary evidence. Others stated the evidence was unambiguous, our whole model of cometary chemistry would have to be rewritten. And then came the chilling possibility. What if this chemistry were not naturally occurring? The detection of carbonyl sulfide, a molecule back on Earth associated with both volcanism and biology, was provocative. Some scientists speculated in hushed tones about active processing. Was this comet a chemistry message? A molecular signature modified by some unknown process? As one scientist said, sometimes the galaxy speaks, not in words, but in molecules. Interestingly enough, all of this was not covert. Webb and SphereX data were stored in ordinary databases, accessible to anyone who had spectroscopic knowledge. But the results were hidden in thick academic reports with dry titles such as Near-Infrared Spectroscopy of Interstellar Comet 3I/Atlas, CO2/H2O Ratios and Formation Chemistry Constraints. The mainstream press missed it altogether. As headlines swirled with political intrigue and Hollywood gossip, the greatest breakthrough in decades gathered dust in preprint servers and scientific databases, waiting for someone to join the dots. In the scientific community, however, the word spread like fire. Emails whizzed between universities. Emergency seminars were called. Scientists spoke in hushed tones about taboo chemistry and messages inscribed in molecules. The world didn't realize it yet, but humanity had just been given its first direct taste of ancient galactic chemistry. Now, as 3I/Atlas blazes back out of the solar system at close to 58 kilometers per second, the questions linger. Was this merely nature's most bizarre comet? A frozen remnant from the galaxy's early days, bearing the chemistry of long-extinct stars? Or something more, a time capsule preserved over billions of years, destined to be observed? That its chemical balances made it through billions of years of radiation and interstellar travel is in itself amazing. It implies protection, toughness, and steadiness way beyond that seen in most comets. Was it made that way? Scientists have no idea. Some believe it's a pristine relic, others that it has been actively processed. All agree on one thing: it pushes everything we believed we knew about planetary formation out the door. As the James Webb Telescope stores its data and SphereX completes its maps, 3I/Atlas disappears into the night. The majority of the world remains unaware it ever existed. But to the people who were able to see the data, the comet altered everything. Sometimes, the galaxy communicates in chemistry. And for those who are willing to listen, the message is one of humility. We might not be unique in our chemical complexity. But we might be much more special than we ever thought.